Hello YouTube, my name's Dave. Welcome to my workshop in a single car garage here in South Australia. Come on in and let's see what we can make. Now what you can see here is my Italian made budget range gasless MIG welder. It uses Fluxcore wire. We'll just get round to the front to show you what the front's like. It's 100 amps I think. You know, quite a nice little unit for for DIY use. I've recently just finished using it after making a wood burning stove for my neighbour. Check the description below, and there'll be a link to to the wood burner. During the course of a very nice to use, but very messy. I mean, although I use copious amounts of Weld spatter release, you know, it really left loads and loads of little weld balls everywhere. So during the evening, during this 12-month period that I was doing it, I did internet searches and YouTube searches, and I found on YouTube several professional welders that were trying these things out and you know, giving the description. Now it turns out that really for gasless MIG you really need it to be electronegative. In that way you end up with a much better weld penetration and about 80% less spatter everywhere. So I thought, oh, I think we'll have a go at doing that. But as I say, I didn't want to do it until the job was finished, you know, in case it turned out and I had problems with it. But in the meantime, I sourced all the components and you know, took the covers off and had a preliminary look, and so here we are. We're now at the point of you know, actually getting round to actually do. Now in this view, it's only temporary put there at the moment, just to illustrate. This is going to be a PVC box with the appropriate capacitor bank inside. That's the full bridge rectifier, and of course on the front, of course, I've fitted as quite a substantial heat sink, because I've no idea how hot this thing's going to get. Of course there'll be a few other components to go inside. There's a bleed resistor to go across the capacitor, and I intend to put some ferrite cores around the cable, you know, to give a bit of inductance. Apparently the real expensive machines that you can actually get for MIG welding, a lot of them have got a voltage control and also an inductance control. Anyway, I thought, well, obviously this one will be fixed, so we'll have a go at that. Now there's no guarantee that it's going to be on this side or the other side. I mean, I did look initially. I mean, there's only one side that I can actually access all the internal components, so don't be surprised if when it's finished it's not on this side, it's actually on the other side. Now, as I say, hopefully this shouldn't be much of a problem. As I say, being you know, having the workshop facilities and being fully competent in engineering as well as electronics and electrics, it should all come out a treat. Now I don't intend to bore you with you know, video of CME drilling holes and pulling through wires and things, so I'll call this it for now. I shall be taking copious amounts of stills during the process, so there'll be a slideshow at the end of this video. So as I said, you'll see no more of this until it's completed and done a test weld. So I'll bring you back then. See you soon. Bye. Hello again. Well, as we can see, the unit is all back together. I've done a test weld with it. It's very pleased with it. It's a nice stable arc, and I reckon a good 60 to 70% less spatter. So it's well worth doing. Of course, I've also fitted down here an external socket. That's the positive earth lead now. So at least it's a little bit easier to pack. the biggest problem I'm going to find, of course, is that you know, I don't use this all the time, and when I put it away, of course, it now won't fit back in the original carton. But I'll have to find a plastic bag and now, when this was a standard AC unit, the 2-position switch on there gave me 17 volts and 25 volts AC. Now it's been turned into a DC unit. I get 25 volts and 32 volts. As I say, nice stable arc, you know, compared to an AC unit. All up about just over 20 hours labour, and the cost of the components 220 Australian dollars. Now, I know you could buy a welder for that, you know, a DC gasless welder, but they're inverter type. This one actually has a transformer inside it, whereas say the modern are quite heavy to move, but the modern ones are what they call an inverter. It's mains that is with a switch mode power supply, and it drops it down to DC. But of course the only trouble with that, of course, is that it'll no doubt be cheap Chinese electronics, which will you know. How long will that last? At least this, it's a solid transformer. Well, I think that just about brings us to this bit. We'll now conclude this bit. So there we have it. That's another project completed, and of course another video for YouTube. There's a few photographs to follow in when this concludes. Nothing else much to say other than please subscribe, ring the bell, hit the like button, leave me a comment, send me an email. The email address is in the description below. So until next time, wherever you are in the world, please stay safe and well, and see you again. Bye.